The history of the modern AC unit and how the invention of the first AC changed the world. The history of the modern AC unit is a long and arduous one. It took a lot of work, trial, error, and innovation to develop this technology. The first AC unit was invented in 1823 by James Harrison. He built his own design for an air conditioner that would cool his home in Philadelphia during a hot summer day. In 1842, William Cogswell created an improved version of Harrison's design with water inside it to create cold air. In 1851, Edwin Drake created a compressed air-driven engine with 2 cylinders that ran on cold gas to create cold air. In 1902, Willis Carrier developed refrigeration systems that could be used in any building or home to cool it. The first refrigerator was invented by French scientist Nicolas Jacques Durand in 1763. Refrigeration has been a large part of American life since then. During the war, several refrigerators were needed to keep food cold. To make them, factories needed a lot of coal or oil, which some factory owners did not have enough of because they were using it for other products. And so refrigerators could not be mass-produced. In the 1900s, refrigerators became more common in American homes and factories. During World War II, the United States saw an increase in the demand for food. To meet that demand, more factories were built to produce food and more farms were able to grow crops. When rationing was implemented during World War II, Americans had to be careful with their resources as they used them wisely. Food was needed most in areas with high populations of people. To get a short supply, some cities had to ration food. The most common source of electricity in America is the coal-powered power plants. The United States is also a leader in economic, scientific, and technological development. This was an important turning point for American history because it allowed them to gain national pride and to become a free society. America's technological advancement is well known. The United States spends the most money on scientific research in the world, which allows them to innovate and find more efficient ways of doing things. The invention of modern air conditioning technology. Willis Carrier invented and patented the modern air conditioning system in 1902. In the beginning, Willis Carrier's invention was a commercial failure. Because it has made it possible for people to live in cities and avoid the heat-related risks that are associated with living in densely populated areas such as urban settings. Invention of modern air conditioning technology has also reduced the energy costs of buildings in cities by lowering the temperature from outside to inside. The invention and implementation of modern air conditioning technology is credited with saving countless lives. The first modern mechanical air conditioner was built by Willis Haviland Carrier in 1902. Air conditioners and other cooling systems have been adopted in many ways for both personal and commercial use. Many people use air conditioning in their homes, especially during the summer when the temperature can exceed. In commercial settings, air conditioning is used mainly for office buildings, supermarkets, shopping malls, and other large structures. What is an air conditioner system? An air conditioning system is a system that uses natural or mechanical means to control the temperature of a building's interior. An air conditioning system typically consists of a compressor, condenser, evaporator, and ducting. It is used in both commercial and residential settings. A compressor is a device that compresses gases or fluids to increase their pressure and thus create work. Compressors are used in refrigeration and gas compression, among other industries. A condenser is a device that cools down the condensed product of heat engines, such as steam power plants and nuclear reactor cooling systems. Air conditioning systems often have condensers as well as cooling coils. A refrigerator is a device that cools the air inside a room or building by means of an air conditioning system. Refrigerators are used to store and chill foods and beverages, such as milk, juice, soft drinks, and beer. The heat from a nuclear reactor is cooled in the same way as a condenser, with water and air being circulated through the system. A gas compressor is used to pressurize the gas before it enters a boiler or turbine. In a gas turbine engine, the compressor is usually in 2 stages. A condenser is an apparatus used to cool or condense a fluid by evaporation into a vapor and subsequently collect that vapor so that it may be reused. A condensed fluid may be used in heat engines, air conditioning, and refrigeration systems, as well as in chemical manufacturing processes such as the production of ammonia, as a refrigerant. The process of condensation using a heat exchanger is called refrigeration. Condensation often occurs in nature when a liquid passes from the gas phase into the solid or liquid phase, or is the result of evaporation. The opposite process, dew formation, is also an example of condensation and happens frequently in nature on damp surfaces. Condensation is the formation of a liquid particle by the freezing of its vapor. The more homogeneous the gas, the less likely condensation will occur. Because any tiny amount of impurity will cause a cloud to form and thereby lower the freezing point. The word condensation comes from Latin condensare, meaning to press together. A material that will conduct electricity, or a device that performs this function. An electrical conductor is usually made of metal and insulated on the surface by a dielectric material such as rubber or plastic. Currents flow easily through conductors without heating them. Conductors may be used to carry current from one point to another, or a conductor can provide a path for heat flow from an electrically heated object to the surroundings. The current density of a conductor is the amount of electrical current that flows past a specific point per unit volume of the material. The resistivity, ρ, of a conductor is the resistance to flow of electrical current through that material. A low resistivity means that there is less resistance to flow and higher conductivity and higher heat transfer rate for the same size piece of metal. The resistivity of a conductor depends upon the material it is made from. The resistivity of copper, for example, is about 1.8 times 10 to 7 mu omega cm, and for aluminum it is about 1.4 times 10 to 7 mu omega cm, and the resistivity of silver is about 6 times 10 to 9 mu omega cm. Other metals have higher resistivities than silver and copper. How we measure resistance is the amount of electrical current that flows past a specific point per unit volume of the material. If a current of 1 mA flows through 1 meter long wire, it can pass 0.1 am. If it flows through 2 meters long wire, it can pass 0.01 am, and if it flows through 4 meters long wire, it can pass 0.001 am. Stay tuned for part 2 of the secrets of the first modern electrical air conditioning unit, and subscribe please.